we may want to actually scale down all of the block meshes slightly so that there is visible space between them, so that the grid lines are not hidden underneath. Let's go ahead and do that now, I guess. And what you actually want to do is scale them up to like the current size they are when they match with other blocks, so that the cohesion between the blocks is sort of more visually apparent. You'll see what I mean if I tweak this a little bit. Let's see what happens if we scale this down. The problem is I'm afraid to scale down the root, if that will affect the distance they travel when we translate them. We'll see. Scale it down even more. Okay, well at this point it seems clear that I'm doing something incorrect, and scaling the root is in fact not scaling the cube, because they're still the same size as they were before. So this is a situation where having the mesh be the root seems to be leading to some unexpected behavior. So I can go ahead and try to add like a scene component and make that the root again, and make the block mesh scale relative to that. Let's see if that breaks everything. This has not broken rotation and translation, and it has not broken the collisions with the walls, and it has remedied the case of not scaling the size of the cube mesh. So now it's just, I've overdone it with the scaling. Here, let's try 0.9. Okay, see, that's closer to what I want. Maybe like 0.95 or 9.2. That's going to be really picky. That's kind of what I want, I think. Where you can still see the grid lines between them. And then when they line up with each other, you can still see the grid lines. But then imagine when they form a match, then they sort of literally touch each other and become one visual shape. Then there'll be no more grid lines between them, and it looks like they're a solid block. That could be a good visual effect. So let's keep that for now. I guess that's good. And now what we want to do is actually, look at the results of these comparisons. So after we've done these 8 line traces, we're going to look at this array, and I guess we'll get copies of the elements of this array. And we'll say, is index 0, 1, and 2 all true? And if they are, then we'll increment some sort of, num matches, which will be an integer, which is just how many matches this particular block is a part of. So we're going to do this for all 4 possible matches. And if they are all true, then we increment our num matches value. The increment shorthand node is useful sometimes. So we need a branch here. I'm going to move this all the way down here so I don't have to worry about running out of space. So I'm just going to duplicate this logic 4 times. This is yet another case for using the sequence node more often, where I don't have to string these together to each other. I can just do them in a sequence. In fact, let's just do that. It's a little less messy, I think. So we'll do this once here, and then again here, and then 2 more times for the 4 test cases. And then change these to the appropriate values: 0, 1, 2, 2, 3, 4, 4, 5, 6. This is that right? 0, 1, 2, 2, 3, 4, 4, 5, 6. 0, 1, 2, 2, 3, 4, 4, 5, 6, 6, 7, 0. That's the kicker. 0, 1, 2, 2, 3, 4. 4, 5, 6, 6, 7, 0. And that will be, at the end we have our num matches, so we'll just return num matches as an output. Initialized to 0, so it's either 0, 1, 2, or 3 based on, I guess 0, 1, 2, 3, or 4, right? Because it could be a member of 4 matches at the absolute maximum. And we can use that number to, determine the score increase when that particular block is cleared. But for now, we're just going to say if it is at least 1, then we're going to change its color and its scale. Something visual. It's not going to affect the logic for matching and clearing or anything. But it should actually give a representation of what's matched, and it should look somewhat like the real game for finally. So we need to get this result and say branch. That's not the way you're going to do it. Branch. If this number is greater than or equal to 1, or say greater than 0, probably more general to say greater than 0, then we'll just change the color to some new color. We have to make these new colors too. That won't take that long. Go to our materials and we'll, let's see. For now, I'll just change these names to block color 0, unmatched, and then we will make this into, we'll give this a few like parameter values. So if we set a emissive color parameter, so I'm going to hold down the 1 key on the keyboard and then left click, and that gives you just a constant value. And if you then right click this, you can convert it into a parameter, which will then allow you to use it in material instances. So I'm just going to call this emissive value, which is actually not what we want to call this. Let's call this emissive strength and set it to default 0, and we'll take another color and multiply the result by emissive strength. And this will be, how strong the light shining out of this material is going to be. So if we have it like this, it's not really any different. It might actually be slightly different, but I think it's the same. And if we were to change emissive strength to like 1000, then this is going to become a very bright sun, very bright sun. And 200 is maybe more reasonable, or that's still a lot actually. 50. That doesn't look too bad, but for now it's still going to be 0 because this is the base object. And we'll just leave this color as a constant value, not a, well actually it is a parameter. I guess I'll rename it then so it's not called none1. I'll call it emissive color. And I'll just call this base color, which is not very descriptive, but that is what it is. And then I'm just going to copy these so that I can more easily create this color 1 unmatched. And then I'm just going to grab this color, copy the sRGB value, and paste it into these guys. Then I'm going to delete this, reroute this, move these guys up, delete this one. And that's that. Now what we want to do is make several material instances for each of these. So if you right click and click create material instance, then I'm just going to leave that as it is, which is going to be a long name, but it's descriptive enough, I think. So color 0, unmatched instance, and then I'm going to make another instance which will be a sibling of that instance and call it matched instance. And then I'll do the same thing for the color 1, create an instance, unmatched inst, and then save it and make another sibling of that one, call it matched inst. Or maybe just I, if you want to make it shorter. Instead of inst, it could just be matched underscore I, but I'm just going to leave it like so. And now the unmatched is going to stay the same as the base one was, but the matched material instance, I'm going to check the box here at the emissive strength and increase it to, 50 is pretty bright. Let's try 30. I mean, that's probably still too bright, because even 0 was too bright, but we can just change the brightness of our directional light in the scene if we need to. I just want to make it obvious that it's different color. So let's make that 30 as well, nice and bright bulb. If we now change some things in the block here, go to the block mesh attributes here in the details panel, change its material by default to, or here in the set color by boolean, we just want to change the material here to be the instance values. Unmatched inst for 0, unmatched inst. Now that's 1, sorry. That's 1 unmatched inst and 0 unmatched inst. That may not be too important, but I want to work towards having a dynamic material as the material on these blocks. And the reason why we want a dynamic material is so we can interpolate between two colors. That way we can have the blocks appear to gradually light up and become brighter. We can go ahead and do that now. It's not that difficult. So what we want to do is let's create a variable called my mat inst underscore dyne. Now that stands for my material instance dynamic. That's a really weird way to name it, but I'm gonna just type in dynamic here and look for material instance dynamic object reference and set that to that. This function should only ever run, once. We're never going to change our color from one color to the other. It's either just going to change between the different states, right? So when either of these occur, we'll just set, let's create dynamic instance. Instead of set material, we're going to create dynamic material instance. And we're going to use these exact things that we have here as the options here. Move this over a little bit. So we're either going to use block color 1 unmatched inst, or we're going to use block color 0 unmatched inst. And oops. Then we're going to set this variable to that return value in either case. So we have a reference to our current dynamic material instance. And we're also going to set the material of the block itself to whatever our material instance happens to be. And so if we did that correctly, things should look exactly the same still, which is what we want. And then when our block changes state, which could happen here even, we don't have to return to the game mode and then change our state. We can let the block handle that itself. But let's go ahead and do that. We can return the value still, but we'll change our own state. Like, we'll return the value for purposes of, scoring and stuff, but we don't need to handle this right now in the game mode. We can let the blocks change their own state. So here we'll just have a branch that says, if num matches greater than 0, that means we now want to transition to the matched state. So we can do that in a function. That way we can change states from multiple places. It's not. So we'll make another function called become matched. And then we'll also need become unmatched, because a block in Lumines can become unmatched if certain circumstances are in play. Like, the timer bar went over some blocks and then new blocks became matched on top of it, and then the clearing of those blocks underneath now break the matches by separating them vertically. So that's a very real possibility. So when a block becomes matched, we need to again use our Boolean, because we have the two sets of colors to choose from. And if it is 1, then we use the color 1 sets. So Now, this is going to be perhaps a little confusing if you're new to Unreal and blueprints in general, but I'm going to introduce a whole new thing called timelines, so a timeline is just a way of like having a value that changes over time according to like a graph that you can create in the editor. It's quite handy and very powerful. Never really used it to its full effect, but this is one case where it's probably helpful to use. Anyway, let's make a call to an event. Now, as far as I know, timelines have to exist in the event graph. Like, you can't do them within functions. So let's just create an event here called add custom event. Let's make an event called color transition unmatched to matched 1. Oh, so color 1 transition unmatched to matched, and then we could have color 0 transition, or maybe we can even handle that within the event itself. So we could do, you know, or we could pass the color as a parameter. There's so many ways that we could organize this, and some are probably better than others, but for now let's just do a branch, I guess. And now we're going to have some variables that will have to be here at the top level. We'll call them target mat inst dyn and starting mat inst dyn, because we're going to interpolate between the two colors, the two materials, and we need to know where we currently are, and that's going to be this variable, and then where we started and where we're going. And these will be set based on whether we're color 1 or color 0. So for color 1, then we will set target mat inst dyn to the you know what, actually it doesn't need to be dynamic, it needs to just be a normal material instance. The dynamic thing is what lets it be a new one, like in between 2 or something like that. So this is just going to be a material instance reference. Same with this one. It's subtle difference. The icon looks exactly the same, but if you hover over it, this is instance dynamic, so we need to change this to material instance reference. Let's go ahead and compile, and then we can set these to the ones that we've already made. So this will be matched inst 1. Let's go ahead and save all because that's unsaved for some reason, and otherwise we'll set it to block color 0 unmatched inst. I think I can rename this to just, I can remove the 1 here because it's not going to be a different event. So it's going to be one of these two is the target, and the starting is going to be what it currently is before any transition occurs. So before we even branch, we can set the starting material instance to our current. I think this will work. It might not work. Okay, it does work. So a dynamic, this can be set to a dynamic one apparently. Apparently that works. We'll see. So we're gonna just so we have keep track of where we started. So this is a linear interpolation. Otherwise, it's going to be like exponential and get it'll change colors more and more slowly. If yeah, you'll see what I mean in a second, or in a minute or 3. But let's add a timeline here, which is going to be a very simple timeline. Just color transition. Doesn't really need to be named anything particularly good. So we want it to be relatively quick, but still slow enough to be noticeable. So maybe, maybe half a second, we'll see. I'm just going to add 2 key value pairs by right-clicking and adding a key here. And at time 0, set the value to 0. And at time 1, set the value to 1. Time 0.5. Set the value to 1. Very simple. Linear interpolation here. And the name of this track, which is, what's going to be output from the timeline node, we'll just call it interpolation percent or something like that. So now when we go back to our event graph, we have the timeline here. Both of these are going to play the same timeline. The only thing that diverged was which material is the target. Then they're going to converge back on the same logic. Play from start, just to be safe. It'll always start at 0 and go to 1. And on update, which means every time we tick and then this has progressed at some amount, we're going to run our interpolation on our dynamic instance. So if we type in like INTER, we have interpolate material instance parameters. So let's update our material instance, our current thing, which is active on our, remember this is what's active on our material, on our block mesh, because of, set color by Boolean. Our material instance dynamic is what is currently shown on our block. So now we're going to interpolate between the starting value, which is what this was before any of the interpolation started, right? So starting material inst is where we're starting, and our target is our target, which we already set up. And the alpha is just the between 0 and 1, if it's 0, it's going to be all starting mat, and if it's 1, it's going to be all target mat. So as we go from 0 to 1 here, it's going to go from the starting to the target. It's delightfully simple. I think it's quite cool. Very powerful, but simple tool, I think. So if I didn't forget some crucial step, which I may have, this should turn the color of the block from its starting color to its, from unmatched color to its matched color gradually over time. And then that'll just be a cool visual effect for the player. And I need to obviously call this event. So I'm going to keep this function become matched, because we may do other logic in the future besides just color transition. We're just going to add a call to that color transition event. And we're going to need, matched to unmatched. We're going to need matched to, highlighted when we do the timer bar. But for now, this is all we're going to do. We can expand it later. So we will go back to here, and I think this is everything we need. I'm almost certainly forgetting something though, so we'll see when we... Oh, one more thing, we need to go to the block and check our determine matches function. And here we need to actually call become matched. If we have more than one match here, then become matched. Otherwise, don't do anything. And return our value to our caller. Okay, that should be good for that. Let's see. I'm also going to remove the... I know I keep saying one more thing, but I'm just going to remove these debug lines so that we can pretend it looks like Lumines and not some weird pinecone thing. And let's see if the magic is real or not. no matches yet. This should be a match here, and look at that, they've lit up. It's just like magic. And of course, if we make more matches, then there'll be more lighting up. And so far, I don't see any like false positives or false negatives. We're gonna have to tweak the colors. I'm no color scientist, but it's still pretty vague to tell. It's hard to tell at a glance which ones are highlighted and which ones aren't. That's one of the things we can do real quick, and I do mean quick. We will go to the block, become matched. We can also do a gradual size increase when they become matched too, so that the size will grow to, you know, right now it's at 0.92 and there's space between them. But if it's at 1, then they'll be completely solid, and that'll help distinguish the matched from the unmatched. So we can have either a separate timeline, or we can use this number unmatched scale and matched scale, which is going to be a float value, or it'll be actually a vector, so it's actually workable as the scale. And unmatched, we're going to have what we currently have, which is 0.92 in all 3 dimensions. And when it's matched, it's going to be 1 in all dimensions. So we could like interpolate between these two using this value. It's probably sufficient. Just a linear function between unmatched and matched scale. So we'll set our block meshes scale, set world scale 3D, or maybe it's actually relative scale. It probably is relative scale, so we'll set our block meshes scale. This is no longer a color transition function, it's a whole visual transition. But now we just scale between these two based on this value, and that should have them grow when they become matched, which is fun. And that's, see, there's one issue. It's going to keep transitioning between them every single time. That's no good. Look at that lone block in the middle. That's sad. That's actually proper behavior, I think. Anyway, what's not proper behavior is this constant instantaneous shrink and then growing again. And what that means is the interpolation is happening unnecessarily for these blocks. So we could tweak something here. One solution I thought was to, have like a current scale instead of unmatched scale. But instead of doing that, we could save a lot of overhead of doing this for every block unnecessarily by just adding a bit of, logic here where we determine matches, and we say if unmatched become matched, right? So like right now it's just always running become matched, but we can get our current state, which we have to update properly, which we're not doing even. So this is a good incentive to do it. So we'll say if my state, let's do branch, if this is equal to unmatched right now, then this is a big node. If my state is unmatched, then call become matched, otherwise do nothing. This nested if statement is perhaps unnecessary, but for now that's fine. And now in become matched, obviously we should set my state to matched. That's a pretty crucial component, I think, of having a state variable in the first place, is updating it when you have a function that's supposed to update it. And now that should hopefully no longer happen. Every block should only become matched once, so there won't be that terrible shrinking problem, and there'll be less overhead for interpolating on all these blocks all the time, every single time we drop down. Only interpolating on the ones that are becoming matched right now. And look at that, that's pretty cool, I think. It's not too shabby. Properly updating the new ones. Alright, I think that's a good place to say good job if you followed along this far. If you put up with my monotone voice and my lack of confidence in my own abilities and blueprints. There's always more to learn. You can become a better blueprint programmer than me with minimal effort, I'm sure. But hopefully this has been exciting and fun, and if you've never done blueprints before, hopefully you're looking forward to more, because there's plenty more coming. So thank you for watching.